Let us look at proposition number 63 of book 10 of Euclid's Elements. The proposition says the square on the major straight line applied to a rational straight line produces as breadth the fourth binomial. So we have AB, a major straight line, divided into its terms at C with AC greater than BC, and we are setting out a rational straight line DE. Now we apply the square on AB to this rational straight line DE to form this parallelogram DEFG. So when we form this parallelogram, it will produce a breadth DG. So what the proposition is saying is that DG is going to be a fourth binomial. Prove that DG is a fourth binomial. We start by applying a parallelogram DH equal to AC square to DE. We apply a parallelogram KL to KH, but remember KH is equal to DE. So indirectly we are applying it to DE. Now since DL is AC square plus BC square, the remainder MF is going to be 2 times AC by BC. Now we bisect MG at N so that MO and NF, they both become equal to AC by BC. Based on the definition of or the specification of a major straight line, we can say AC and BC are straight lines incommensurable in square. AC square plus BC square is a rational and AC by BC is medial. DL has been applied to a rational straight line DE. DM is rational and commensurable with DE. 2 times AC by BC, which is MF, is medial. Here, AC by BC is medial. So that means its multiple will also be medial. MF is applied to ML. MF has been applied to ML, which is equal to DE. So that means MG is rational and incommensurable in length with ML. That is DE. AC is incommensurable with BC. And we know the proportion AC is to BC is equal to AC square is to AC by BC. So which means AC square is incommensurable with AC by BC. Now AC square plus BC square is incommensurable with 2 times AC by BC. AC square plus BC square is rational and AC by BC is medial. So they are incommensurable, which means DL is incommensurable with MF. DL is equal to AC square plus BC square and MF is 2 times AC by BC. So we can say DL is incommensurable with MF. Now, which means DM is incommensurable with MG, because remember D is a common side to both DL and MF. Common side we can say because DE is equal to ML. So since one side is common, the other two sides are the basis of these two figures, DL and MF. And since they are incommensurable, that means the sides will also be incommensurable. So DM and MG are also rational and commensurable in square only. So therefore DAG is binomial. So we have proved that DG is binomial. Now we have to prove that it is the fourth binomial. So AC by BC is the mean proportional between AC square and BC square, which means MO, which is equal to AC by BC, is the mean proportional between DH and KL. AC square is DH and BC square is KL. So we can write it as DH is to MO is equal to MO is to KL and DK is to MN, sides of DH and MO, is equal to MN is to KM. again sides of MO and KL. So this can be written as dk by km is equal to mn square. Product of the extremes is equal to the product of the means. dH is incommensurable with KL. dH is incommensurable with KL. So is dk and km. Since the area is incommensurable, the uncommon sides which are not common to these two areas will also be incommensurable. AC square plus BC square is going to be greater than 2 times AC by BC. Again, this we have already seen in previous proposition. That means DL is greater than MF, which means DM is greater than MG, because DE is constant for both of them, both the areas. So the only thing that can be said is that DM is also greater than MG. So we have dk by km is equal to mn square, which is equal to 1/4 of mg square. So if you take the square on mg and take the square on mn, you will notice that since n is the midpoint, mn square is going to be the 1/4 of mg square. And we know that dk is incommensurable with km. So that means dm square is greater than mg square by the square on a straight line incommensurable with dm. So dm is rational and dm is commensurable with de. So based on all these, we can say that dg is a fourth binomial straight line based on the definition of a fourth binomial straight line. So that is proposition number 63 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.